Okay, today's lecture is on magnetic force uh, do not do any work. Magnetic forces do no work. This is the name of the topic. As we know, according to the Lorentz law on magnetism, that is the force on a charge in the magnetic field, is given by F is equal, that is the force, Q V cross B. This equation implies that force is perpendicular to the velocity and magnetic field. That implies that the force is not doing any work on the charges moving in the magnetic field, because force is perpendicular to the plane in which velocity and magnetic field lie. But in some cases it seems that magnetic forces do work. For example, when a car case is lifted by a magnet, it is naive to think that magnetic forces do work, but here which agency is doing work in lifting the car case? That basically we have to address to that problem, because as you know that this is a question generally asked by the students to the teachers, and in lifting the car case it seems that magnetic forces or the agency which do the work, but somebody is working in that process. Who takes the credit of doing work in the process of lifting the car case? That we have to see. Here, we know in a car, when magnet acts on the car case and lifts it up in space, the car case contains magnetic dipoles, spinning electrons, all lined up in a particular direction, and that all the magnetic dipoles lined up is equal to the surface current. So we can model the problem in a different way. So if we don't take the car case in the first instance, let's take a charged ring, a rotating charged ring that is just equal to the car case in the given situation, because there in the car case the electronic moments lined up in a particular direction is just equivalent to the surface current. So here, let us take a magnet here, and these are the magnetic field lines. Of course, the magnetic field is stronger when you go closer to the magnet, and becomes weaker when you are a little far away from the magnet. And in this magnetic field, let us say there is a circular ring, charged one, and this circular ring is rotating with the rotational angular velocity omega. And in the let us say that it has a charge density lambda. So it's a circulating ring having a charge density lambda, therefore it is equal to a current. And that current, if I calculate this current, that is lambda is equal to, Q by T, that is Q, if I calculate this Q, that is 2 pi, if it is radius is R, 2 pi R lambda by T, that is I is equivalent to 2 pi by T is omega R lambda, where omega is angular velocity. So this charged ring circulating equivalent to a current, it will be lifted up by the magnet. While it is being pulled up, one feels that it is the magnetic field which does the work. But as we know, the magnetic field is not going to do any work, because according to Lorentz equation, the magnetic force is perpendicular to the net velocity. As such, the speed will not change, although the velocity changes, but the speed is not going to change, and that implies that magnetic force are not doing any work. So if I resolve this, let me investigate which agency is responsible for doing work, or is there any network being done or not. Let me say this magnetic field, let this magnetic field be resolved into two components, inward radial component and upward vertical component. The radial component, when the ring lifts up, this radial component of the magnetic field is being cut by the ring. I want to find the force on the ring in the magnetic field. The force is, as we know, F equal to ILB. That is the formula for the magnetic force. Is F equal to the current, L is 2 pi r. But which magnetic field is being cut when the ring is being pulled up? That is BR. I mean, it is the radial component of the magnetic field which is being cut by the ring when the ring lifts up. And F is equal to what's current that we can calculate from here, omega r lambda, that into 2 pi r BR. So F is equal to 2 pi r square lambda omega BR. This is the force. So this is the force on the ring when the ring lifts up. When the ring lifts up. But if I want to calculate the work done in this process, whichever agency it may be, but the work done in lifting the ring up can be obtained as like this. Let me rub it off. Delta dW, let me see, when the ring lifts up by a little smaller amount, dz, let me suppose, that is F dz, that is F is 2 pi r square lambda omega BR dz. This is the work done in the process, and this work done increases the potential energy of the ring. But now, who is doing the work? But that we have to see. But when the ring lifts up, in that process something else happens. What happens when the ring lifts up? There's a motional EMF, and for that we have to calculate the motional EMF. Maybe what we are calculating, that the motional EMF will try to reduce the angular velocity of the ring. I mean, it will try to reduce the rotational energy, and that is the motional EMF reduces the rotational energy of the ring, and that rotational energy may be converted into this potential energy. So for that we have to find what is the motional EMF created in the ring. As we know, the motional EMF is just the rate of change of flux, that is EMF E equal to minus d phi by dt. But when the ring goes up, it is the flux cut by the periphery of the ring that's important. Something like this. It is the ring going up. It is this periphery which cuts this magnetic field, which cuts the radial magnetic field. The radial magnetic field is being cut and it crosses through the periphery, and this flux change gives rise to induced EMF. But what is the flux? Is minus d phi dt. What is the flux that is being cut? That is this flux which passes through this much of area, that is 2 pi a, that is periphery, into dz, the amount it goes up into magnetic field. But which magnetic field? BR. It is BR which is being cut. So the EMF produced is equal to, that is minus 2 pi a BR dz by dt. This is the induced EMF produced in the ring. But this induced EMF produced in the ring produces electric field, circular electric field, which acts on the charges and slows down the ring. The electric field which is being produced is given by the formula. Induced EMF is integration of E dot dl. So induced EMF we know, that is minus 2 times A dr dz by dt is equal to E into 2 pi a. It gets cancelled from both the sides. So what do we get? Electric field, that is minus br dz by dt. This is the circular electric field which acts on the ring, and this electric field acts opposite to the angular velocity and slows the ring down. So as the ring goes up, it at the same time slows down. So what we had to find here, I have found the electric field, circular electric field. So now I will try to find the force acting on the ring. The force which acts on the ring, can be obtained in the following manner. The force acting on the ring, can be obtained as follows. So it is the ring here, it is being pulled up by the field lines, it is being pulled up, and now what is the force? By the circular electric field on the charged ring. The force is simply F, that is minus electric field into charge, that's 2 pi a into lambda. So force is just equal to minus, forget about negative signs already with the electric field. So minus Br dz by dt 2 pi a lambda. This is the force on the ring. But the force is, it's a tangential force on the ring. The tangential force on the ring, on the ring produces a torque. So what is the torque? The torque acting on the ring, which acts opposite to the omega, and when it acts opposite to the omega, that will slow down the ring. So torque is given by, that is F into A. I have used A as radius, but I should have used R as radius. So torque is just F, that is minus Br dz by dt 2 pi r square lambda. This is the torque. Now, the torque acting on the ring, in the opposite direction to the omega, it will slow it down, and once it goes up, it slows down, but at the same time potential energy increases. So what we can say that the potential energy of the ring increases at the cost of the rotational energy. So no agency is doing work. Or the vertical component of the magnetic field is working at the cost of the radial component of the magnetic field. So here we have the torque, but we know torque is equal to what you call as, again let me say what dW is torque d theta. So what is the work done by the torque in slowing down the ring? That is minus Br dz by dt 2 pi r square lambda into dt. dt gets off. So we have here it is d theta. It's d theta. Here it is it is d theta. Yes. So it is minus Br dz by dt 2 pi r square lambda omega dt. This gets cancelled because we know d theta is omega dt. So here again we have a rule. The rule is the change in work done in slowing down the ring while moving up is 2 pi r square negative sign lambda omega Br dz. And here lies the answer. It is the decrease in the rotational energy of the ring, and it is the increase in the potential energy of the ring while going up in the magnetic field. The work done by in the process in lifting the ring up is being compensated by the decrease in rotational energy. So it implies that no agency is doing work, or the ring goes up at its own cost. Thank you, and this is the explanation for that magnetic forces do not do work.